which one to use, composition or inheritance? So inheritance, we have already discussed this, let's see, or explain this, what is the inheritance and how to use it. And if you see here, the inheritance, the relationship of the inheritance is a. What does that is mean? For instance, if you see here animal, I have defined this class here animal. Now a dog is inherited, also inherit this animal. So it means dog is animal. Dog is animal. This is an inheritance. And the composition, let's see, a class has, or let's see, has a. And you can see here, this is animal and this is a dog. And in this case, we have say, as I already said, dog is an animal. This is inheritance. So what is the advantage and disadvantage of this, of inheritance in general? So advantage is course reusable. Subclasses get all the features of the parent class. So any features of this class, it will be directly used in this class, and easy of override or extend the behavior. For instance, speak, you could also add another function which is, let's say, relevant only for this dog. Just an example, you can define diff speak, and if it has a different behavior, you can just add it here. And this advantage here is tight coupling between base and subclasses. So as you can see here, this class is already tied with animal. So uh, now if you change the animal class, you have to take care to change also the dog class. This called a tight coupling. And also it's hard to modify or scale. And if you modify the animal class, you have to take care of all the inherited classes. I mean, or the base class, not the derived classes or child class, and check all the functions that have been used here. It might be, it will be broken, let's see. And the composition here, it has a relationship. What does that mean? It has, for instance, engine, and I have here a car. And if I have inherit this, for instance, engine, so it won't be, let's see, as inherited. Why? Because car is car. If we see the principle of the inherited is a. So let's see, is a car is an engine. This is wrong. It should be car has an engine. So that's why we have to use composition. And here we have defined the engine here, but for instance, I have defined the car and only using let's see, initialize the another class which is composite, the class here, which is car has an engine. But I will say this is not, let's see, a good uh, example. Not a good example. It's not a good or efficient way to define the engine. Imagine that you have to change the, you would like to define another engine, for instance, electric, or maybe another with some different properties. So here we have, you have to change this manually every time you would like to change the engine. It's composition, but it has also a problem. It's tight coupling here. Now, the good example of this, you can see defined an engine. Let's see, defined an electric engine, and this car here, it has, when you initialize the car, you have to define which engine has to be, uh, let's see, place, or let's see, for this car. And you can see here, I have defined the engine one, which is this class, and engine 2, which electric class, electric engine. Now, if you initialize this car with this engine here, it will try to use the engine. If it's with engine 2, it will be electric engine. So this way here, the car it's not taking care about which engine is, let's use. For instance, and today I would like to use general engine, let's see, and maybe 2 days later I would like to use an electric engine. So it's easy just to replace these initialization. And as you can see here, the difference between this and this here, I have to change this, for instance, to the electric. If I have electric engine, I have to change it electric. So this means I have to change the code, which is not a good idea to change the code after, let's see, implementation. But here you can see it's loose coupling. It's the car has no idea, or let's see, it's not responsible for which engine is sending. For example, the user sending engine, the user sending electric engine. And the advantage of decomposition is more flexible and decoupling. See, more flexible, you can use different engines, and decoupling, it's not defined fixed, as for example this example here, which is of course composition, but it's not a good way to define this. And it's like modular design. So this engine here, or maybe these, can be used in a different classes without any issues. For example, if you have a truck, just use truck and initialize the engine, and it will should work perfectly. And now this advantage, it's need more initialized component. If you see, I have to initialize the other classes, and also this one here, and slightly more complex. It's really complex, but when you let's say used to use this composition, it will be somehow easy for you. So let's just compare between this and this. I mean, inheritance and composition. As we said, is a, and the composition has a. So code reuse, you can use, of course, inheritance. For example, if you have one class, you can use it in any different class, just import and inherit it from this. For example, car, truck, airplane, I don't know, and anything. And the composition as well, you can use composition. Flexibility is rigid. It's when you initialize, let's say, when you create a inheritance, it's hard to change it. But he highly flexible. You can change the engine of whatever you want. And design complexity is simple, but here it's you need more setup, as you can see this one here, initialization. And when to use inheritance of when to use inheritance, when to, you have, if you have, when the relationship is a, so you have to use inheritance. And the composition, it has, for example, this just example. And let's just focus now on uh, a computer vision example here. Let's see, I have an image operation. I have defined this class, and the image operation, it might be, let's see, grayscale operation. So I have, for each image, I have different operations, and I have created this abstract class. Let's see, it's not abstract, it's interface class. And here I have in here, so you can see grayscale operation has, or let's see, is an image operation. And you can see here I have initialized, of course, the, the parent class, which is this one here, and they have different apply. For instance, here I have, for grayscale, I have different apply. For blurring, I have different apply. For threshold, I have different apply. And for edge detection, even, I have different apply. For the morphological operation, I have different apply. And you can see this is the class that I have defined. Now I need a pipeline, which is, let's see, a composition, I would say. So you can see image pipeline, it has operations. And what is the operations? It might be edge detection operation, it might be threshold operation, it might be blurring operation, and etc. Now, if you see here, I have to add the operation that I would like to apply to this image, and it will just adding as in a list, let's see. And if I would like to process, I will just go through one by one, and giving the, let's see, the result of the first operation, it will be as an input to the next operation. Let's just like this. And if you would like to visualize this, you also need to have the same operations, which is already defined in this self operation. Now let's just jump to this. Let's say I have to create a pipeline. I have to create a pipeline which is called edge detection pipeline. For the edge detection pipeline, you have to add operation, grayscale operation, blurring with a filter kernel size, this one here for instance, and the next one is edge detection. And this is the pipeline of edge detection. Of course, we will discuss this in a few more details with numerical examples of the edge detection, canny algorithms and others. And the next pipeline is threshold pipeline. You have to make a grayscale operation, blurring, and threshold operation. And for this one, it's as well. So it's, as you can see, I can apply whatever I need for this, for each image. And here I have three different let's see operations on the same image. And here you can see I have to visualize this, which is this one has to be an image indeed. As you can see, visualize steps, it will receive an image. And here I have the copy the image for instance, just to keep the original image from the different make a copy of the image. So the image itself, this one here, it won't be changed if I have something, let's see, applying some operations. And this operations, it is just taking the operations that I have added in this pipeline here for instance. I think this should be okay. And of course, if you have any question, just drop a comment below, I will answer it definitely. And this is some questions: is a book is a library, or a library has a books, and etc. Just to understand the inheritance and composition. That's it, and see you next time.